Alright, so we're going to be doing more problems from 11.6. Here we have number 8. The sum of sk going from 1 to infinity of k e to the negative k. It's the same question as the previous problems. Use the ratio test to determine whether the series is convergent or divergent. Now, if you recall, we use what? The limit of a and absolute value of a n plus 1 over a n as n approaches infinity, and that's what we're going to be doing. So what is a n? A n is k e to the negative k, and what would a n plus 1 be? It would be k plus 1 times e to the negative k plus 1. So that is the same as, well, let me write it down first. The limit as n approaches infinity of a n plus 1 over a n is equal to the limit as n approaches infinity of a n plus 1 is k plus 1 times e to the negative k plus 1 divided by a n, which is k e to the negative k. So let's go ahead and simplify this a little bit. Here, what do we get? If we put together k plus 1 over k, and take a look here, the numerator is the same as a to the negative k minus 1 over e to the negative k, right? So that's the same as e to the negative k times e to the negative 1 over e to the negative k. So this disappears, and what you're left with e to the negative 1. Or simply, you can write it, well, let's leave it. You can also write it as 1 over e. Remember, e is just a number. We can pull it out. That's 1 over e, the limit as n approaches infinity of k plus 1 over k. Right? K is positive. It's from 1 to infinity. So this is going to be positive. This is positive. You don't need to put the absolute value anymore. Now, if we divide everything by k, what do you get? So you get 1 over e, and the limit as n approaches infinity of 1 plus 1 over k over 1. As k approaches infinity, this is going to become 0, right? And so what do you get? You get 1 over e times 1 over 1, or simply 1 over e. Now if you remember what e is, right? So 1 over e is going to be less than 1, right? So e is simply .71 something. So 1 over 2.71, this is going to be less than 0, less than 1. So the series is absolutely convergent. By the ratio test. Since the terms of this series are positive, absolute convergence is same as convergence. So the terms are positive, so absolute convergence is really the same as convergence. So the series is convergent. So this is number 8. And we're going to start with the root test. What is a root test? Let's start with a new page. Okay, so what is the root test? So here we have 3 parts. If the limit of the nth root of an, absolute value of an as n approaches infinity, equal to L, which is less than 1, then the series sum of an as n going from 1 to infinity is absolutely convergent. And therefore convergent. Now, if the limit equal to L, which is greater than 1, or the limit of the nth root absolute value of an as n approaches infinity equal to infinity, then the series is divergent. And the third part here, when it's inconclusive, and you guessed it, if it's equal to 1. If limit the root test is inconclusive. Okay, so let's go ahead and do a few problems. Okay, so let's do number 21. In number 21, they're asking us to use the root test to determine whether the series is convergent or divergent. Number 21 is the sum, as n approaches 1 to infinity, n squared plus 1 over 2n squared plus 1 to the n power. So an is simply n squared plus 1 over 2n squared plus 1. So using the root test, we take the limit as n approaches infinity of the nth root of absolute value of an, that's the same as the limit as n approaches infinity, the nth root of absolute value of an. This is positive. N squared plus 1 to n squared plus 1. N is going from 1 to infinity. N is positive. So I don't need the absolute value. I can just write it as n squared plus 1 to the 2n squared plus 1. Right? And, oops, I forgot here to the end. So the n power cancels the nth root. So that's equal to the limit as n approaches infinity. The whole thing comes out because these two cancel each other. N squared plus 1 over 2n squared plus 1. So this is number 21. Now divided by the largest power in the denominator. The variable raised to the largest power in the denominator. That's a limit as n approaches infinity of n squared divided by n squared, that's 1, plus 1 over n squared, divided by 2, this cancels each other, plus 1 over n squared. So this is going to approach 0, this is going to approach 0 as n approaches infinity. So that's going to give me only what? 1 plus 0 over 2 plus 0, which is 1/2. So 1/2 is less than 1. So what can you say? it's less than 1, then the series is absolutely convergent. So the series is absolutely convergent. By the root test. You can include that. So this is number 21. We can do more problems. Okay, so let's do number 24. In number 24, an is negative 2n to the, over n plus 1 to the 5n. So the limit of nth root of absolute value of an as n approaches infinity is equal to the forgot the limit. The limit as n approaches infinity of negative 2n over n plus 1 to the 5n. So this n, cancel this n, right? So the root disappears, and what are you left with? You're left with the limit as n approaches infinity. Absolute value of negative 2 is 2. So you have 2 to the 5th. This remains. So you have, at this point, 2n over n plus 1 to the 5th power, which is the same as the limit as n approaches infinity, 2 to the 5th n to the 5th over n plus 1 to the 5th power. 2 to the 5th is 32. You can remove it from the limit 32, limit as n approaches infinity. Okay, so you're left with n to the 5th over n plus 1 to the 5th power. I'm going to try to do a little bit of algebra maneuvering. Isn't that the same as 32 limit 1 over n plus 1 to the 5th power over n to the 5th? So you have 1 divided by this, so 1 multiplied by n to the 5th over this. So these two are the same. And then I can rewrite this, I forgot to put n approaches infinity, as 1 over n plus 1 to the n the 5th power. Okay. Now we're dividing this by n. What do I get? I get 32, the limit as n approaches infinity of 1 over n over m, that's 1 plus 1 over n over 1 to the 5th power. So this is going to approach 0, and you're left with 32 times 1 over 1 to the 5th is 1, 1, so the answer is 32. Obviously 32 is greater than 1. So the series diverges by the root test. The series sum, and we go to 1 to infinity, negative 2n over n plus 1 to the 5n. Okay. Probably if you're wondering why we did this, it's because we couldn't have done anything here. If you divide by n here, you're going to have n to the fourth. You had to manipulate it a little bit in order to see what you're going to get in here. What is this will give you? What would this approach as n approaches infinity? We cannot raise this to the fifth power. And it's going to be very long, and it's not practical. So we had to do a little bit of maneuvering here, and that's what we did in this problem. Okay, so I'm going to stop here. All the tests, all the problems are relatively close to the two problems that we just did. I'm going to stop here with this section, and that will be the end of 11.6.